Today, lecture number 2, which is related to mass. Section 1 is going on, and that section was forces and motion. And today we are going towards our next lecture with the topic mass, weight, and gravity. And if I talk about this, okay, mass, weight, and gravity. And if we talk about this, then I will say here, mass, weight are not the same thing. And here we will also learn about gravity. And I will go to explain out towards explaining the difference between both of them. So first of all, I should explain the gravity, then I will should go towards mass and weight to be comparison over there. Gravity attract all masses. Basically, what is gravity? Gravity, gravity is a force which attract all objects over there. It attracts all objects over there, or all the masses over there, it is going to attract. But if we notice about this, masses is really very big, such as a planet of Earth over there, then anything near the planet or a star is attracted to it very strongly over there. So this has three important effects over there. On the surface of planet, we can say it makes all the things to accelerate towards the ground or towards the planet. So with the and all with the same acceleration, that is 10 meter per second for gravity over there. Then I will say here the gravity is having its value for Earth over there is 10 meter per second square, even though a small page, a particle is falling towards Earth will fall with the same acceleration of 10 meter per second, and even 70 kg big rock is falling towards Earth, it is remaining to fall with the constant acceleration called the gravity over there. So anything which is attracted towards the Earth, this is the important effect of gravity, that on the surface of planet it makes the things to accelerate towards towards it over there, with the towards the ground, we can say, for the Earth case over there. So I will say on the surface of planet, on the surface of planet, um, on the surface of planet, the planet makes all the things to accelerate, or it makes all the planets, like I'm using for planet over there. It makes all the objects to fall towards Earth or towards ground over there, because we are talking according to weight with respect to Earth, which we can measure on the surface of Earth over there on our planet. So it is making with acceleration of gravity with 10 meter per second square, taking in your syllabus, but its exact value is 9.81 meter per second square over there. It gives everything a weight because it is being multiplied, and it gives weight to everything over there. It gives weight to everything over there. And if I go in more detail, then I will say here, it keeps the planets, moons, and satellites in their orbits. And the orbit is a balance between the forward motion of the object and the force of gravity pulling inwards over there. For example, I am saying here that this is the Earth, and there is the orbit, which where the moon is moving or revolving around the Earth. Then there is a force of attraction of gravity, which is moving, attracting it towards itself and providing centripetal force to move this in a circular path and giving its the force to move in that circular path over there. So this is Earth, this is the moon. Both are revolving around this because of gravity. So gravity is overall from the star towards planets, planets towards the moons is provided in a same way over there. If I go for weight and masses, then I will say they are not the same over there. And mass is just the amount of stuff of an object, and mass is basically quantity of matter, quantity of matter present in an object, in an object over there. It is measured in kilograms by using a physical balance or electronic balance over there, or electronic balance. And it is a base quantity, and it is the quantity of matter which we will have to use in our laboratory, and in our daily life we use kg as the mass measuring unit over there. When I talk about weight, it is caused by pull of gravity. Weight, I will say it is caused by pull of gravity, caused by pull of gravity over there. And this pull of gravity, we can say weight is measured in newtons, having also measured by spring balance, or by the Newton meter over there. And if we talk about this weight, we can say in most of questions, a weight of an object is just the force of gravity pulling it towards the center of Earth in most of the cases over there. And an object has the same mass, whether on the Earth and the moon. Okay, mass can be same for the object, but weight will be different because moon will not attract with the same gravity. It will be having its gravity value of our moon case is 1.62 meter per second square over there. So when we talk about this, we can say an object has the mass, whether it is on Earth or on the moon, that will stay as the same over there, but the weight will be different. And a 1 kg will weigh less on the moon because that will be multiplied by 1.62 meter per second square by using its formula W is equal to mg, or like that. And weight is the force measured in Newton over there using spring balance or Newton meter over there. Mass is not a force. Mass is not a force over there. And we can also say it is that is measured in kilograms. I have already explained about this. So if I am going to relate gravity, mass, and weight, all of these three terms, then we will use the formula over here, which should be written in the form of weight is equal to mass multiply gravitational acceleration or gravitational field strength. Gravitational field strength over there. So we use the formula W is equal to M multiply G over there. So always remember that weight and mass are not the same. Exactly, we should memorize this. That if someone is going to the market and saying my weight is 50 kg, he is wrong according to physics. His mass is 50 kg and his weight according to Earth is not 50 kg. Weight is 500 newtons over there. And the letter G here represents the strength of gravity, and its value is different for different planets. On the Earth, it is taken as this G value as 10 meter per second. and 10 meter per second square, or 9.81 meter per second square. You will use in your A-level standard over there. For the gravitational acceleration, this was for Earth and this is for Moon. Moon is having 1.62 meter per second square over there. So here we can say the formula is hideously easy to use. And if you want to make its triangle over there, as was done in the previous lecture with the acceleration and speed formula, here I will say is W is equal to mg over there. And you can easily manipulate this formula over there. And we should use this formula for calculation of gravity over there. If I talk now more about the next section of this lecture, I will say what is related to forces and friction over there. Then I am saying here forces and friction. So if I talk about force over there, then force is basically a push or a pull over there. Force can change the shape of object. Force can stop or tend to stop the moving object over there. Force can accelerate an object or tend to accelerate. And friction is a resistive force in the motion when body is moving in the normal on the ground. For example, I'm running, I will have to face the air resistance over there. That is called related to friction. And if I am walking on the surface of Earth, then there must be the friction over there. So if I talk about the forces, then I will have to go for their little bit types over there. Number one, I am going towards gravity. Gravity is basically pull of the planet are close to the planet, this acts straight downwards. Gravity is a force which attracts the object, attracts the uh, falling objects, falling objects towards it, towards itself. Attract the falling objects towards itself related to gravity over there. If I talk to the next type of the force over there, that is a reaction force. The reaction force is basically, we can say, for example, a book is lying on the table. Then weight is downward and the table is exerting the reaction force exactly perpendicular to the surface away from it. For example, I'm simply saying here, this is the surface of the table over there and a book is lying over it, and this book is exerting its weight downward, then upthrust or reaction force is exactly above it. That is the reaction force exactly perpendicular. And so if the surface is horizontal, then the reaction force acts straight upward. So this is the reaction force in place of this weight force over there. After that, there is electrostatic force. Reaction forces, like I can say perpendicular force acting normally upward, acting normally upward over there. So reaction force is going to explain us about the exactly perpendicular and reaction force if action force is gravity present over there. So we will have to go towards that is electrostatic force. Electrostatic force of attraction. That is, I will say here, that is the force between charges. If the charges are both positive, then there will be force of repulsion, and direction of the forces depends upon the type of charge. If they are like charges, then they repel. If they are opposite charges, then they attract over there. So force of attraction between positive charge Q and negative charge minus Q over there, then this is going towards this is going towards this, and there is force of attraction between them, and electrostatic force is present over there. Then there is thrust. Next force is up thrust or thrust over there. Thrust is a push or pull of an engine or a rocket spreading something up over there. So if I will give here the example how a body is going to swim, how a rocket is going to upward direction. Even though he is throwing his burning fuel towards downward direction, then the rocket is moving in upward direction. Our body swimming, our object swimming over water over there, and we can say a rocket going upward direction over there. Then we can say all of this should be taken as thrust over there. If I talk to the next type of force, that is drag force, that is the resistive force which is present inside the atmosphere, which is we can say air resistance or friction. Air resistance or friction, which is present over there in case of resistive force, which is going to destroy deterioration between the motion between the parts of a body over there, which is slowing the things down over there. After that, there is lift force, which is going to put or move the object upward. Uplifting for any object should be taken into account in this case. If I am going towards number 7 over there, then I will say there is a tension. Tension is a force which is present in a string over there to make it turgid over there. That is force in a rope. We can say in a rope or cable, we can say in a rope or cable should be taken into account for this one. So we can also draw how the force is acting on a body over there. Then I can say, for example, I'm taking a small car over there, which is moving over the surface of the road over there. Then I'm saying here it is having some rolling friction and it is having its weight acting downward. Weight. Upthrust or reaction force is exactly provided by the surface of the road as a reaction force. And there is a thrust which is moving in this direction so that it can accelerate in this direction. After that, there is a drag force or resistive force which is acting in backward direction to stop the car over there or providing the resistance in its pathway over there. So it is free body diagram. So don't go towards the drawing that it is not so much clear or like that. Just this is thrust. This is a reaction force. And if I say for the downward acting, that is related to weight of the force over there. That is weight of the force. So whenever we are going to get the chances are there are the loads of the force acting on you right now. And if we are talking about this, then we will simply say here how we should go for it. So we can say here that whenever if object of weight feels a reaction force back from the surface of it, so otherwise it will keep falling. If the earth is not supporting the car, definitely it will fall downward. And when an object is moving in a fluid, then it is he feeling like drag force. Our car is moving on the road over there, is feeling the air resistance over there. So this is the complete introduction related to the forces over there. And now I am moving towards friction, and I will say here friction is always present. Friction is always present to slow down the objects over there. To slow down the objects over there. If there is no friction, no one can stop over there. For example, you are throwing a ball and there is no friction, it is not going to stop over there. If an object has no force like propelling it along, it is always slow down and stop because the friction is because of friction, it is going to be slow down over there. So friction is a force that opposes a motion. It opposes the motion over there. And if I say here that to travel a steady speed, things always need a driving force, or we can say counteract the friction. I will have to my engine going to work on. For example, my car is going at the full speed of speedometer. Why? The engine is still on, because we can say there is no acceleration at that point, but I will have to compensate with the friction. While, for example, you are saying there is a speedometer with 200 kilometer per hour. You have got the maximum speed over there. When then the speed is not changing, then it means acceleration is equal to zero. And you are saying, sir, there is F is equal to ma, accelerating force is equal to zero in that case. Then why engine is still working over there in the fifth gear or sixth gear over there? And we can say it is still going on. Then the reason behind it, you will have to counteract with the frictional force over there, which is opposing the motion continuously over there. So to travel the steady speed, always remember things always need a driving force to counteract the friction over there. Friction occurs in three main ways over there. When we are saying how the frictions are happening or occurs with the three main ways over there. Um, then at number one, I will say friction between solid surfaces which are gripping. For example, you are saying how this table is being formed over there. It means there is a friction which is gripping over there. So friction between solid surfaces, friction between solid surfaces, solid surfaces which are gripping over there. Gripping. For example, a nut bolt, for example, anything which is fixed in some other object and going to fix over there. This is because of solid surfaces to be fixed over there. Friction between solid surface which are sliding past each other. For example, you are removing the tires of your car and you are going to pull it. Then I'm saying friction between solid surfaces which are solid surfaces which are sliding over each other, which are sliding over each other, or which are sliding past each other over there. So in this case, we can simply say here that all of these frictions are going to, if you want to reduce the both types of friction by putting a lubricant, for example, you are providing a grease between them, then friction will decrease, but will not finish over there. And friction between solids can often cause wear of the two surfaces in contact, then wear and tear in heavy machinery is going to happen over there. And the third type is related to air resistance, air drag, or resistance or drag from fluids, resistance from fluids. That can be in the form of liquid or gases or air over there. Liquid, gases, or air over there. On all of these cases, we can simply say here that resistance is provided in the form of drag force in that case. So most important is by far in reducing drag in fluids is keeping the shape of object streamlined. As like we can say, like sports cars, their shape of face is streamlined in this form so that they can have to face the resistance and this narrow face can cut the resistance over there easily, and it can fast. Our bullet train over there should also be taken into the examples. And lorries and caravans have deflectors on them that make them more streamlined and reduce the drag over there. Roof boxes on cars spoil their streamlined shapes over there. If some one has made a roof box over his car, then streamlined shop is going to slow down them, and more air resistant should the car will have to face. And the opposite extreme to the sports car is a parachute, which is about as high drag over there. So we can say, as you can get this, the whole idea in fluid friction is always increases as speed increases in the air. Here I will say here, for example, you are moving with the speed of 30 kilometer per hour. Then if you take your hand out, you are not feeling so much friction. But if you are going with 200 kilometer per hour, and you take your hand out, you will face a large amount of resistive force to be present over there. So we can say friction always increases as the speed increases. Friction from drag force always increases as speed increases over there. So remember that this was related to our frictional forces over there. In the next section, we will go towards investigation of motion with using some experimental setup over there. I will try to use some picture to explain that complete motion over there. So follow me in the next video. Thank you so much for today. This was related to forces and friction, with the types of forces and friction, how different ways they are going to affect, and why they are needed for slowing down during the motion over there. Thank you so much for today, guys. Take care of yourself a lot. Kindly subscribe my channel. Thank you so much.